Hey, welcome everyone. I hope first 2 days of DAC were just wonderful for you. And it's great to see so many of you survive the various parties that went on last night and made your way here right from them to the floor. No sleep needed. Yes, indeed, here's my projector. So you heard from Sean O'Kane what's going on in the pavilion. This has been a pretty good setup in the pavilion. Interesting talks. We try to cover a wide range of areas for you to all get some more information and interact a bit with the pavilion presenters. Again, as you saw, we're going to have a talk about integration. You can just buy it all built, or can you still innovate when you get some really strong components to start your design? We're going to have Wally Rines with the one-on-one, which should be really great way to just get up close and personal with the CEOs of the leading EDA companies and see what they're thinking. And a good friend of mine, Dinesh, is going to talk about the way he made new kind of transistors, gallium arsenide, that deliver power at about 95% efficiency instead of the 85% or so efficiency that you get today. And this is a huge deal for, of course, all those server rooms that are mostly turning power into heat, and then a little bit of the power gets used for the actual server activities. It's not quite that bad, but if you can get that waste down from 15% to 5%, that's just a huge deal. So I'm real interested in that. I encourage you all to go to that. And then we have a couple contests where at 3 o'clock there'll be the award ceremony. Folks have worked really hard to both design a hardware design on top of a FPGA platform. And then there's also a whole, can you hack into tools to basically get security holes in products as they're being designed? So this is a real interesting area. We have to, for security, it's end-to-end, from concept through early implementation into deployment, into updates in the field, everything. We just have to think about security. And so this is an exploration into that whole bit. And there's a contest of, could this be done? And you'll see the award winners in that bit. And then we'll have another teardown of the iPhone 7 at 4:30 in the pavilion. We have the poster sessions. I saw a lot of folks over there, kind of browsing through the various topics. What are these people inventing that are either doing some designer IP track, or out on the floor there's the work in progress. So these work in progress are papers that, they haven't yet written the paper, but they have some early research information that they've gathered and they're sharing it with us all. So that can be a way to get a taste into what the researchers are thinking about going forward. And that's out in the Trinity Street foyer, and there's drinks and snacks out there. Training day, of course, is tomorrow. This is a chance to go in depth with some of these topics that a lot of your colleagues are doing. You can expand your knowledge and value to your company by getting some skills that are related to what you're doing now, but let you reach out into a broader area. And without further ado, I'd like to invite Tyson Tuttle to come up and talk to us about accelerating the world of IoT.
Thank you. All right. Well, good morning, everybody. Take a deep breath. Wake up. I've been in Austin for 25 years, and came here from California and managed to survive my first summer. So you guys are getting to experience all of that. One of our mantras here is to keep Austin weird. And I saw someone earlier that had a T-shirt that said "Keep Austin nerdy," which I think that we're all, thank you for doing your part to make Austin Austin. Hopefully you all are having a good time. I am COO over at Silicon Labs. Our offices are just down the street. We've been based here since we were founded in 1996, so over 20 years ago, doing silicon software and solutions now for the Internet of Things, but started in RF and CMOS and mixed signal integrated circuits. We went public in 2000, and now have about 1,300 people, about half of them here in downtown Austin. So welcome. We've been on a journey to do chips, but also now have been targeting the Internet of Things for about 7-8 years now, and embedded devices and the Design Automation Conference is a wonderful venue to really talk about this. I think you look at the innovations, the decades and decades of innovation in automation of the electronic design process, and how it's enabled us to design more and more complicated semiconductors and systems. And I like to think of the Internet of Things as kind of, now we're going to be applying a lot of that same methodology through multiple technologies into every segment of our society and the economy. So the analogy between how we're applying these techniques to chips actually is going to achieve scale. And I think that the Internet of Things is one of those pieces of the puzzle. And really, this talk is about how do we accelerate that and make that happen, and what's it all going to look like. And really talking about this from, at least my perspective, coming at it from a silicon and a hardware design standpoint, but then what do you have to put on top of that to make it happen? So let's just talk some numbers to start. So 2025 sounds like a long way away, but it's about 8 years away. And they're talking about 70 billion connected devices by 2025. And just to put that in context, today there are about 20 billion connected devices, and I'll go into a little bit of that. And the economic value per year, 8 years from now, of the Internet of Things, of connecting all this stuff together, they're talking about $11 trillion. And just the global GDP, the gross domestic product of the entire world economy this year is about $78 trillion. So if you fast forward that to 2025, global GDP will be about 100 billion. And the improvement in productivity and the growth, there's inflation that goes in there, but about 10% of that, you can think of that as being driven by the fact that we're automating the world economy and delivering all of this value to help the economy grow and really raise people out of poverty and inform the world and make things more efficient. So that's pretty big, and to put that in another perspective, the semiconductor industry, and it depends on how you count this, but the semiconductor industry is about $350 billion. So the value of a lot of this, it's not just the hardware, but it's in the applications and the data and everything that's going to be coming along. So this is a major trend, and it's going to really transform the economy and the way we live. If you kind of break that down, we have about 7.5 billion people in the world today, about 4 billion smartphones, about 2 billion computers that are connected up to the internet. But you've got about 15 billion other connected devices. So this trend has been going on for a long time. This is an exponential graph. So, and that's about a 20% CAGR. So going from 15 billion in 2017 to about 60 billion connected devices outside of smartphones, outside of computers by 2025. That's an accelerating rate, but an average of about 5 billion devices per year. So this is a significant opportunity for the products that we all design to get out into the economy. And we're really in the phase where this is starting. It's like a snowball. It's a snowball effect. We're starting to see more and more applications, more and more volume. And it's a very exciting opportunity and time to be in the industry. And another really exciting thing about this is not just one application, it's not just one customer, it's not just one company doing this. This is tens of thousands of customers, thousands of applications, and really an opportunity across the board for a wide variety of technology. So, what's it really going to take, to support this growth? And I would make an argument that the infrastructure, kind of the critical mass of technologies are there, exist today to be able to support this growth. If you think back to, the jet engine was invented in like 1937, but it took 50 years for airplane networks to get deployed where we can, jump onto airplanes and get anywhere in the world. And so just because the technology is there doesn't mean that it's fully deployed. So you've got to separate that out. And I kind of view this as this is going to take multiple decades to play out. But you've got the ubiquitous networks, you've got the internet, you've got mobile networks, you've got the cloud, you've got big data, artificial intelligence, all the algorithms that are running in these compute engines, we're making them faster and more capable over time. Now we've got, user interfaces. You've got PCs, you've got smartphones, you've got the applications that run on there, you've got people's ability to interact with this data and interact with devices in ways that 10 years ago didn't really exist. You've got the connectivity technology, not just wired connectivity, but you've got LTE, you've got Wi-Fi, Bluetooth, lots of different, Zigbee, lots of different wireless connectivity. And I would argue that most of the connectivity that's going to be required to deploy 60 billion units is going to be wireless. It's not just going to be, we're not going to run 60 billion wires. A lot of it is going to be wireless. A lot of it is not going to be plugged in. It's going to be autonomous and low energy and that sort of thing. But that connectivity, those connectivity standards continue to evolve, but the capabilities of those are sufficient for many of these applications. The algorithms for security, there's a talk later on today about how to hack into everything, but the methodology, if you properly deploy security technology, and we'll talk a little bit more about this, that does exist today. It's really about making it easy and make it easy to deploy and best practices, and to continue to evolve that over time. And then finally, the hardware platforms. That 60 billion devices, there's going to be a chip inside each one of those, thank God. And the IoT SoCs look a little bit different from the types of chips that have been deployed in computers and smartphones, and so we'll talk a little bit about that. But that is starting to become available in high volume, and that's a very exciting trend as well. So how will we get to that? How are we going to make that 45 billion more connected devices? How are we going to get there? And first, you have to really what's the driver? What's the economic driver for doing all this? And the fact that something gets connected, when you connect a product, if it's just standalone and it's fixed and it doesn't hook to anything, it's just static. But once you connect it up to a network, that's adding inherent value, and that's really where this whole inflection point is happening, is that connection. We'll talk a little bit about what are some examples of that, and why connecting something creates opportunity and an imperative and an incentive for people to deploy this type of technology. The network effect, the fact that there are ecosystems and multiple devices. It's not just one device getting connected. It's the fact that many devices are having to work together, and that creates a multiplier on the value as well. And then you've got the fact that things have to evolve. Once it's connected, now that product lives into the future, and you have to manage, you have to update, you have to evolve that functionality, and that creates new business opportunities as well as challenges, and how to do this properly and how to afford that. So this is really the outline of the talk. I'm going to step through this, but that's really the way to think about the deployment and how this is really going to happen at scale. David Rose from MIT, coined a phrase. It's hard to imagine that things that won't be connected. I mean, this is a great book if you haven't gotten it. A tennis racket, you've got, that's going to be connected. It's going to tell you, how bad your swing is and how to change. And that's just one example of the many things that will be connected in our lives. If you look in our homes, a few years ago, you had, maybe your garage door, a phone, a computer, an access point, or something like that. If you and you had different connectivity tech, you had Wi-Fi and Bluetooth, and your garage door might have been some sub-gigahertz proprietary. If you look kind of today, there's more stuff. I mean, how many people in the audience have more than 10 devices hooked? Come on, wake up, everybody. Everyone has more than 10. You're at the Design Automation Conference, for God's sakes. Yeah, whatever, you're asleep. So 20? You got 20? Few? I have 33 IP addresses in my house, which is a pain. But so you got light bulbs, you got air conditioners, you got appliances. You've got maybe some of those devices that used to be one protocol are now speaking multiple protocols. It's not just going to be one one protocol that's going to win. It's going to be multiple depending on the use case. You've also got the fact that the majority of this stuff is going to be wireless. If you're going to be upgrading, you don't want to run wires in your walls and do all that sort of stuff. So there's, we see, kind of the home is the thing that's like the most visible for us, right? So that's what we all think about as IoT. And so there's a good story. So one of our customers, Chamberlin, they make garage door openers. You might have a LiftMaster in your home, and you had a button. We did a great chip. It was like single chip remote control button that talked to the garage door, and so that's been a feature for a long time. And and they do both residential and commercial. But in the residential, they started adding connectivity. They started adding Wi-Fi, cloud connectivity, so you could make sure your garage door is closed, check the status. Kind of the beginning of automation of what to go on. But they also have this commercial arm. So they the big freight doors in warehouses that go up and down, and a lot of businesses try to figure out how to they're trying to differentiate their products. They're trying how do you avoid the race to the bottom of who has the cheapest garage door opener, and we do that in the semiconductor industry. Every industry is trying to figure out how to differentiate and how to create more value. So on the commercial side, there's a lot of regulation. For instance, if you have air conditioning inside a building, you've got to put that down. There's got to be some way of making sure that it doesn't stay open too long. And so if you add sensors and you add control to these commercial doors, there's actually subsidies that you can get from the government in California to close those doors automatically. So that, because they knew how to do that automation, create those systems, the back end, the apps, and the algorithms, they were able to add that on the commercial side, and now that's a feature, and if you don't have that feature, you can't compete with them. And so that's something that they can charge for. And so this concept of being able to add connectivity to old school devices, to you're saving energy, you're creating value, and you're also complying with regulations, is an interesting story. If you look across the spectrum of opportunities for connected devices, we talked about the smart home being really interesting, and you started with the garage door and all that, but actually the industrial applications are the place where the most value is, where there are clear economic drivers to save money, to improve productivity, to be able to comply with regulations that are going to drive the deployments of these types of technologies throughout industry. Commercial buildings, lots of different places it's not just one thing. And on the industrial side, that's where I think the majority of the value is going to get created, and it's also just very broad, lots of different things. So I wanted to share another story about power tools, which you think, well, why does a power tool need to be IoT? And so we've got this customer in Milwaukee, and not the hotbed of IoT technology, but they were actually a pioneer in putting lithium-ion batteries into drills. So they invented the Sawzall, which are really, if you don't have one of those are fun to operate. But so now that all their stuff is wireless, and it's actually interesting. From a lithium-ion battery, you can get more torque than you can out of the plug in the wall. Kind of think of your Tesla. Your Tesla can accelerate faster than a gas-powered engine. And so that, and also with lithium-ion, there's enough battery, storage where you can run that tool all day, recharge it at night. And they again, they were looking at how do we enhance the value, our differentiation value proposition of our products. So let's add connectivity. Let's add Bluetooth, because you only have so many switches and controls on. It was really to add a better user interface. Bluetooth. Every contractor has a smartphone. These tools are all kind of geared towards higher end, commercial builder type applications, not so much consumer. And so they started to do that, and then Well, that's kind of cool, but who's really going to pay you more because you've got an app on your smartphone? But they started to add, multiple types of new features to this. They made it so that if you don't have your smartphone, the tool doesn't work. Because that's a big problem on job sites. So they would if you don't have your smartphone, the tool doesn't work, and then that prevents theft. And so that's a big deal, right? You also, every time the smartphone sees the tool, it records the location. So you know where the tool was. You don't want to be paying people $75 an hour to go walk around and look at tools. So that asset tracking aspect is really important. It turns out that on a lot of large-scale installations, there's like, for instance, when you're installing solar panels in the desert, if you over-torque the screws, everything works just fine for about 180 thermal cycles, and then stuff starts to break, and it's really expensive. So if you over-torque, so they when they were bidding for this job with the utility, they said, okay, well, we can program a special torque curve to be able to, where it torques it just right so you can avoid that problem. That's value again. It turns out when you're installing electrical, they sell these crimpers that when you hook up to the it's insulated, and when you hook up to the electrical power line, you have to crimp, and it knows who did it, where it was done, when it was done. It does and basically they could automate the the regulatory compliance and paperwork, and just make that all work. You don't have to actually fill stuff out. It eliminates a whole bunch of manual operations. So they were able to take this really simple idea of, just add Bluetooth in and migrate that into, a whole new business model, charging for services, enhancing their value proposition, where they kind of separated themselves from the competition. So this is just one example. There are thousands of examples like this, but a very interesting example of how IoT technologies are changing industry. Cities are another place. You've got parking, you've got street lights, you've got bus stops, you've got utility grids. There's a lot of value in cities, to connect things. And again, a variety of different connectivity technologies. Coming back to our graph, metering was one of the first applications where they started connecting these. And so you look at energy meters. It was really the goal was to eliminate the meter reader. You don't have to send somebody out to just read the meter. Save on truck rolls, save on labor costs, and that sort of stuff. In the UK, the government's kind of got onto this, and in the UK they're rolling out 100 million Zigbee-enabled meters over the next 5 years. But it's not just about saving labor. It's about data. It's about monitoring, trying to reduce energy usage. So, to be able to, if you show consumers how much energy they're using and how much it costs, they actually end up using less energy. So that's a really, really good thing. There's also, in Austin, we've got fairly progressive utility. It's a city-owned kind of unique utility. And if you install a thermostat that's connected up to the internet, they have a way to connect with that and pre-cool your house. If you've noticed, it's kind of hot here, and it's like this all the time. Please don't move here, but we got a little bit more room. But so you avoid the fact that when we all come home, you turn on your air conditioner and you get this really big peak power consumption. So in the middle of the summer, that drives, massive requirement for power plants. So their goal is to try to pre-cool your house, reduce that peak power consumption and avoid building a power plant, which are really, really expensive things. So their, utilities aren't in the habit of, writing you checks, but here's an example of where actually writing you a check and deploying, subsidizing the deployment of this. It's not really impacting your comfort, but it's helping them better manage the utility grids. So again, I would put this in an industrial case of being able to deploy connected technology in a way that is really creating value, helping to make things more efficient and more convenient and all of that. All right, And then, health is certainly in the United States, a big challenge to control costs and to, deploy care as widely as possible. And I think that, IoT and connectivity technology there is going to be able to help us bring down the cost, in a lot of ways, from applications and data and all that. But really, if you look at an example of an IoT application, this is one of our customers, Propeller Health. So they put a little button on top of your inhaler so that it talks to your smartphone, and every time you push that button, it can monitor, when and where are you taking your medicine, and then they're looking at ways of, saying, okay, well, are there patterns? Every time you go through this one spot, do you end up with asthma and all that? I mean, there's like, I think it's like 1.1, like 10% of that value, that $11 trillion, is really an improvement of health outcomes. And the example of this of very low cost way of adding monitoring and tracking of medicine use. And are you using your medicine? Are you do you need a refill? Do you need can you give people feedback that, hey, maybe you shouldn't go here because every time you go there something happens. That basically it can be a virtual consultant to help doctors and help patients achieve better outcomes and maybe use less medicine. Maybe highlight, hey, you aren't really using this stuff. Do we need to keep giving it to you? And all that. So healthcare is another big area where connectivity technology and deploying that in ways, there's all sorts of monitors and things, sensors that are going out there that are making things interesting. All right, so that's kind of just a kind of a view of like how some of the value is getting created and the market opportunities. There's a long tail of applications there, and that's really what makes this the most exciting area that I've worked in. So Silicon Labs, we started the company. We were doing components that went into bigger systems, lots of mixed signal and RF and Mentor tools and Cadence tools and Synopsys tools. Got to give everybody props. But my background is I'm a chip designer, so I come from the hardware side. I mean, I've designed plenty of phase lock loops and band gap references and done plenty of layout and all that sort of stuff, and have the privilege of now thinking kind of big picture and how all this stuff comes together. And kind of our journey was, it got to where those components, it's not, it's just that hardware started to get the opportunities got smaller and there's more commoditized. And if you really look about how you're going to scale a company, you don't want to be integrated out, and you don't want to be bundled out, and you want to increase your value proposition. And you start thinking about IoT, and that's where really the silicon is now the heart of the system, right? Like the CPU is the heart of a system in a PC, the processor and the modem, and a Qualcomm, Intel, Qualcomm. In IoT, embedded, diverse range of applications, and the ability to control your destiny, control the integration path, and increase the value proposition. That's easier said than done, though. And so we've been on this journey for 7-8 years of really looking at what it takes to address this trend. How do you address tens of thousands of customers? How do you design hardware for all of these different applications? And so I want to just talk a little bit about some of the aspects of that have been interesting and challenging as we move forward. And I can't get up and give a talk at a technical conference without showing a chip plot. So this is actually my favorite slide here. I thought you all were going to clap and go ooh something but this is an example of what one of these little IoT SoCs look like. You've got embedded flash memory, embedded RF. You've got an ARM processor. You've got energy management. You've got a bunch of digital logic, and you've got to have a portfolio of these devices to support the different applications. You've got to have different memory configurations, different sensor interfaces, different, so you have a lot of these chips to do. And the question is, do you try to build a platform that you can serve everything else, the entire market with, or do you do specific optimized things for each application? And we're trying to work on this platform approach so that you can do, one hardware platform, get multiple products out of it, and address as many applications as possible within the space. So try to throw out as big of a net as you can. The other challenge with the smart, we talked about the tens of thousands of customers. How do you scale support across all those different applications? You got to make this stuff easy. One of our core values is simplicity. How do you make complex software and hardware easy to use so that the industrial customer in Milwaukee can easily design this in and focus on delivering the value in their product, not in designing the RF and worrying about the low-level registers on your chip. We started taking these chips and putting them into modules that were pre-certified, that have an antenna. You just take the module soldered into your device. You don't have to do FCC certification of the end device. And so that makes it easier if you're not buying that many units. But if you're selling tens of millions of units, you can take the hardware, design it right down on the board, and that's worthwhile for us to invest the time in the support side. So the simplicity of designing this in and the simplicity of support is important for the scaling of the business. And those were a couple of the challenges. How do you build the portfolio? How do you deliver simplicity and be able to scale your support without, to be able to afford to do that? And so that's been a big part of the challenge. This is my favorite diagram. Junko from Double E Times is down here. She's taking feverish notes, but I think back in 2014 I drew this out on a napkin and you put it in the magazine. So I drew it up fancier this time for you. So I hope that's okay. But you've got, when we talked about in the home, you've got multiple protocols. In industrial applications, you have legacy protocols that you have, and sometimes you have to talk Bluetooth to configure something. You have to talk to a legacy network, and you might have to talk to a Zigbee network. And so the fact that you got multiple radios, multiple protocols, multiple stacks running is very important in terms of being able to address, again, that wide range of applications. You've got security. You've got hardware security, software security. You're optimizing these devices for low energy consumption. A lot of the devices are operating off of batteries. The integration is different, right? In your mobile phone, you've got maybe 20 chips, each one optimized in process for what it needs to do: the audio, display driver, the processor, the memory, the flash, the RF. All of those are different. Here in IoT, you can't afford, with those 15 billion units or 5 billion units a year, the lower you can push the cost, the more that's going to get deployed. And these are not cell phone level functionality. These are simple man-to-machine type things in a lot of cases. Simple sensors that need to be low cost, low energy, optimized. And so that really means that all this has to be integrated onto a single chip. This is a different chip than you would put in a phone. It's not running Linux. It's got to have integrated security that's optimized for these types of applications. It's got to interface with all the different applications. I mean, it's really interesting engineering to figure out there's 1,000 sensors you can do. How do you make this thing work with as many of those as possible and minimize all the external components so that we can be integrating everybody else's stuff, not the other way around? And so that's a great opportunity. It's really interesting stuff to be working on, but it is different from what, the way things have looked in a lot of these other large markets. And it's not just about the chip. And this is, now we've got almost half of our engineers are writing software, not designing hardware. And so there's multiple protocol stacks. There's real-time operating systems. We talk about security and how do you make all that work together? How do you optimize that for low energy consumption? And more than that, how do you get paid for this? How do we get paid for what we do? How do you get paid for the software? And yes, it's a differentiator and a value on top of that, but it's the investment that's required on the software side and the evolution of that is is a critical challenge, because you have to be able to afford to do all of this and do it in a way that is easy to use and make it simple and abstract a lot of the complexity away from what designers really are trying to do in their end product design. And security again, the IoT is going to scale, and that's good. But as these applications get deployed, if you have garage doors, if you can come in and hack that, that's probably bad, right? And as these things scale and get larger, that becomes more important. And there's a lot of innovation here that optimizing this for low energy consumption, best practices about how to keep the keys safe, how to implement the hardware security, how to implement the algorithms, in the software stack, as you're doing device management, as you're doing, you're connecting devices up to the network, keeping that safe all the way through, protecting the data all the way up to the cloud, so that it's not just the security at the device level, it's got to be all the way through the end application and where all that data is stored. And best practices, usually these things that happen are because somebody hasn't used the best practice. They've left the temp password on the IP port. I mean, come on, don't do that. So don't let people do that. I mean, that's not good. So, both in terms of the chip design, the software design, and the way that we deliver simplicity, security has to be kind of like, front and center at, how to make that happen. And I can't emphasize that enough. All right, so the network. Bob Metcalf lives here in Austin. He actually lives like a quarter mile from our office. He looks down, makes sure we're working every day. And he's at the University of Texas driving innovation, but he was the inventor of the Ethernet and the CEO of 3Com Corporation, and he coined Metcalf's Law. And I've been trying to figure out how to create a Tyson's Law, but I haven't figured that one out yet. I don't think you can actually, most people that come up with laws like this it's not intentional. But it's basically that the value of a network is proportional to the square of the number of nodes. And that's a powerful concept, and that really applies, as we're, adding more and more devices to the network, that's creating value. And actually they say that about 40% of the value created with IoT, that $11 trillion, is really the fact that it's not just that you're connecting the device. That creates value, but the fact that there are these ecosystems. And the fact that these devices are working together and operating together and easier to control, that's really the network effect is creating a lot of the value. We're working with a lot of the leading ecosystem providers and watching this stuff really come together. You've got the Echo, you've got HomeKit, you've got Google, you've got Comcast, you've got a lot of stuff going on over in China to create these networks of devices, interoperability to make things work together so that they're easier to use, easier to deploy, and you can have use cases that combine the functionality of various things. So, a good example of that is lighting. So, lighting, I'm going to say, is the next killer app. And not just because, we're really excited about all the light bulbs that are getting shipped out there, but it spans across these different use cases. There's a lot of commercial, industrial applications, certainly in the home, in cities. So it's the volumes are going to be really high. And the value is going to be evident. You've got energy savings, better performance, additional services, and you've got the fact that lighting needs to be connected to a lot of other things. One light bulb is interesting, but multiple light bulbs are a platform. So, here's the humble light bulb. We've seen the transition from LED or from incandescent to LED, and that's well underway. To drive efficiency and longer life. I don't like replacing light bulbs. I mean, if you look, inside the light bulb, you've got, electronics for power conversion. It's pretty simple to add connectivity to that, and it's got to be low cost. It's got to work at 125 degrees C too. So light bulbs get hot even when they're efficient. But you've got the Philips Hue, you've got a lot of commercial stuff coming out, and those are networked, and there are applications that get driven from that. Here's a home. Each year worldwide, there are 2.5 billion light bulbs sold per year. Now, they're all not LED, and they're not all connected yet, but as the cost curves come down, you hit an inflection point, and that will make it so that the connected light bulb will essentially be, you won't want to have one that's not connected. In the US, there are 40 light bulbs per household, so that even just here in the US, it's a large market. And the bulbs must work together. They need to form a network. It needs to be robust. It needs to work when your internet connection's down. It's got to be interoperable with the switches. When you're building new construction, if you're using automated light bulbs, you don't have to run the wire to the switch, right? So you save on installation cost, on the electrician, the hours that they spend running wires through a house. There's a lot of features. You've got dimming, you've got color, you've got the ability to change the color temperature throughout the day so that in the morning you don't get woken up too quickly, and then it kind of wakes you up with more blue, and then in the evening kind of turns more like firelight and it puts you to sleep. And when you turn on the light at night, it knows, okay, don't blare it on, keep it, this intelligence of how lighting works and the health benefits, for mood and sleep is really valuable. And then you've also got the control. You can set timers, when you come home, things just kind of come on, makes it more convenient. You can save energy by turning things off in rooms, integrate that with other sensors in the system. So this is going to be very high volume, very interesting market, driven by clear value propositions throughout the chain, and by the fact that we're going to hit an inflection point where adding the connectivity is a fairly small portion of the overall cost. So, but it's all back to this. The chip is just down there on the bottom. That thing gets put in a light bulb. There's a bunch of software. It's talking to a Zigbee network. It's talking to Bluetooth. It might be talking to some legacy network as well. You've got that app layer, the language that IoT can be a Tower of Babel. Everything talks a different language. Here, with lighting, they actually need to speak the same language without going up to the cloud. You don't want to turn the light and then goes to the cloud and comes back. Oh, then the light came on, or maybe the reliability is really important. So they have to speak, a HomeKit language, or a dot, which is the Zigbee cluster library, implemented on IP, or a Zigbee network by itself. And then you've got to connect it to the cloud to be able to get the information back and forth and do the programming. When you're not home, you want the thing to work. And so there's additional software that gets layered on top inside the device that enhances that interoperability and enhances the functionality that's really embedded in that software stack that has to go in the device. And that is an important part of getting these things to be scalable and to create the most value out of what you're trying to do. You've got, Charles Darwin. That's a great picture. He's big beard and birds. It's not the strongest, but the most adaptable that survive. And I think this concept of evolution, once we sell a chip, it's not, we talked about, it's not just a static function. It's got to evolve over time. Your phone is getting updates. When you bought your phone, it didn't have this app. You get a security hole. That gets plugged. And so the evolution of these devices, it lives into the future, and that's an important concept. You embed that. You got to have flash, and you got to have enough memory to store multiple stacks, and there's a lot of complexity with that. But it does create incredible value. It also creates an opportunity that, as a hardware designer, you're able to monetize that functionality and potentially offer additional services. Or the fact that it runs Bluetooth 5.0 right now, but when Bluetooth 5.2 comes out, you want to make sure that product, you've got to guarantee that thing is going to be upgradable in the future. And so that's an opportunity to get paid for more than just the hardware that you sell at one point in time. And as a semiconductor, the semiconductor industry hasn't figured this out completely, but I think it's a very interesting opportunity. And actually, the EDA industry, given that we negotiate the pricing contracts for software, and they charge us for maintenance and license, why can't we do the same? That's trying to figure that out. So let's talk about the journey. We've gone through select the hardware. If you're designing a coffee maker here, You've got, you got to select the hardware, the software platform. You got to develop the product. You've got to, the mobile, the app, the user experience. You've got to connect it to the cloud, to Amazon or Microsoft or IBM or one of the cloud vendors. And then you've got to figure out how to deploy and manage those devices over time. So this is when, when our customer is talking to us, they're not just thinking about the chip, they're thinking about this, hey, I got to do all of this stuff, and how do we make that easy, and how do we make sure that that scales over time, right? It gets away from the conversation of, how many pennies are you going to give me this chip for X number of kilobytes, to, how do you help me get this product into the market and make it really truly valuable and something that I can, a lot of these IoT applications, they're not just throwaway, right? You buy that, $1,000 coffee maker and you don't want it to be obsolete in a year. And so you've got to really think pretty big picture and long term about how all this comes together. A good example of a device that I like a lot is the Amazon Echo. And the voice actuation, you just talk to it. And when these things first came out, they had about 70 functions. And that you could tell it, now it's got like 1,700. You've got, it integrates, if you're designing a connected device, you want it to say works with Amazon, Alexa. I just got a new sprinkler controller. I had one of those old school ones where you got to go out and say, and it gets it gets hot and you got to turn it up and you got to turn it down. It's a real pain in the rear, right? Stuff dies, and it's so the new one is Rakio. It's like a California company, and and it looks at the weather and it hooks to the web and it's got a nice user interface and it talks to the Alexa. So you can say, water the yard, it's getting brown, and that's pretty cool. So so voice control, that's starting to get this to where it's kind of like, back in the day, it was like I was the only person in the family that could program my VCR, right? I still, am, there's no VCR anymore, but it's like you've got to make this stuff intuitive and, it's to where it's not, how does my mom do this stuff? All of us in here can figure out, we're all the IT support staff at our houses, right? But, if you think about that scaling across that big market, it's got to be easy, it's got to be foolproof. Nobody wants to be talking security algorithms and worrying about updates and all this. They just want it to happen. And we're starting to see that come together, and that's kind of a multiplier on seeing all this stuff get out into the market. So last block diagram, so we've talked about, what goes into that espresso machine. You've got security, you've got to get that to the cloud. You've got your cloud providers, you've got the app, you've got a device management service. And let's say you're only selling 10,000 or 100,000 espresso machines. Maybe you might want that to come from, you may not want to create that from scratch. And maybe you might want to monitor these devices and do all this. So that's another opportunity to create that device management. But all of this stuff exists. The chips, the apps, the cloud, all this, but it's going to take time for this to get deployed throughout the economy. And you really can't design a product today without it being connected. If you're an industrial company and you're not thinking about how to connect and the value that creates and how to extend that over time and make that a fundamental component of your value proposition, it's a race to the bottom of commoditization. And so this is a tremendous opportunity. Kevin Ashton, another guy who lives in Austin, not that Austin is the center of the IoT world, but we're doing some pretty cool stuff around here. But he coined the phrase the Internet of Things in 1999. He was giving a presentation at Procter & Gamble about the new trend of RFID and how that will change the supply chain. And the title of the presentation was the Internet of Things. So he got to coin a phrase. I guess it's maybe not a law, but he gets credit for that. But the Internet of Changes has the potential to change the world just as the Internet did, maybe even more so. And I kind of view the technical revolution that we're going through as an economy and as a society and as a world as kind of equivalent to the Industrial Revolution that we went through in the 1800s. I was just in Germany. I went to the German History Museum and went through, like, from the Middle Ages to, all the way through, to the modern day, and looked at, the impact of the Industrial Revolution and the changes in politics. Everything was reactionary, and things were, labor and all this stuff going on. And then we had, globalization. So that was kind of pre-World War II. Now, since World War II, there's been globalization of supply chains. We have tremendous improvements in productivity and being able to make, products and things cheaper and get those to markets and make those more accessible across the world. But it's also had huge upheavals in terms of politics, in terms of policy, very reactive, around the world to what's going on. A lot of people lose their jobs and frustration, but at the same time, it's created opportunity and it's created value and all this. And we're going through another one of those times now with semiconductors, and if you look at the cloud, smartphones, robotics, electrification, artificial intelligence, big data, telecommunications, IoT, battery technology, all these things are starting to come together. I mean, IoT is kind of the embodiment of a lot of those trends. It's part of this greater thing that's going to change the way we live. Not just make it more convenient to turn on our lights, but it's going to disrupt healthcare, retail, transportation, energy. I mean, we're talking like half of our economy, and I haven't even named the way it's going to change the other half. And this is going to, it's going to displace jobs. In like 100 years ago, 80% of the people worked on farms. And today, 3% of the world's population works on a farm, or something. It's a small number. So if you told people 100 years ago, all your jobs are going to go away because the tractor and all this stuff are going to make things more efficient, they would have thought that it's the end of the world. But it's actually freed up people's time to go and work on other stuff. We would have all been working on farms instead of doing fun chips and software and all that sort of stuff. So it's like, there's a lot of scary aspects to, the deployment of technology and, changing of business models. There's going to be winners, there's going to be losers. But, I like to think that, it's kind of the opportunity of our lifetime in terms of interesting engineering, interesting, use cases. We all like to solve problems, but, we've also got to keep an eye on how the technology impacts the world, impacts our society, educate people, teach people about, not just about how to connect your device up to the internet to do something, but how this is going to change, and think forward, and let's figure out how to not be reactive to this trend, but actually leverage it, to harness it, to make the world better, to grow the economy, to lift people out of poverty and ignorance, and to make the world a better place. But engineering, it's definitely a fun place to be, and I appreciate your time to let me tell you part of our story. Thank you. I think we've got some time for questions. I almost nailed it on time.
So there's microphones at the front of the audience. We've got the spotlights on them. If you have a question, come on up.
Come on, you got some question. Wake up. Somebody who's designing an embedded product, security, something.
I'll ask a question. You had on your slide the graph of the various market segments, and then there was a couple of next thing. You're going to make some predictions of what, after the smart home and the factory and so on and so forth.
Well, it's interesting. So last year we did $315 million in business in IoT chips and software and stuff. And we had 60 customers over $1 million. We had no customer over like 3% of revenue. And you start looking at there's lighting, there's home automation, there's security, there's water sensors, there's almost all 60 of those customers do different things. So there's a big long tail, and 60 customers over $1 million, like 5,000 total. So it's, the number of, anything you can think of that's going to get connected is going to get connected. And the challenge is, how do you do the right software and how do you support all that to make it happen? So no big prediction, it's lots of little predictions.
Thanks for the wonderful talk. So you talk about security is something very important for coming up with the SoC chip for IoT. Can you talk a little bit more about how do you guys test the SoC against hacking? How do you make sure the implementation actually fulfill the security requirement that you have laid out?
Yeah, so we do kind of these hackathons internally to where it's we kind of challenge people to break things and to think creatively. Sometimes our customers help us with that process, and just kind of staying current with what are the best practices, helping to drive that into the standards, but really just always trying to think through how to break it, how to break in. I mean, and it's we had a guy come to talk to us from, I think it was Tech Insights, one of these companies that takes apart chips, and they do this for a living. We've also brought in some consultants to try to help us break things, but he was describing how some of these really sophisticated attacks where they do power analysis, and they go in and figure out how to hack your debug port and download your code and put this snippet of stuff in, and it's it scares the shit out of me sometimes. I mean, it is people will always be thinking up new ways to break stuff, and you got to stay on top of it. And then the most important thing is, when you find something, you need to be able to fix it without having to have everybody return stuff and put it back. And so this is one of the advantages of connecting things up and being able to do these device updates and stuff like that. And in your phone, that's a big application. How do you do that in these machine-to-machine applications that don't have a user interface, that are stuck in a closet somewhere and are going to sit there for 20 years? That's you got to think ahead, and you've got to convince your customers to add additional functionality and capability to be able to address these things as they occur.
Got another question here?
Is it time for one more question?
Sure.
Okay. Question related to the earlier gentleman who asked. We have security on one end of the spectrum and debug on the other end of the spectrum, and they both don't talk. If you want to debug, you need to at least open up security, and if you want security, you can't debug. So how do you come up with a balance? We can secure all the doors, but you have to leave a sliver of window open to do some amount of debug, even in a closed platform. So how do you compromise between security and debug? It should still be secure, but you should be able to debug, but you should be able to debug and still secure. What's your thoughts?
Yeah, I mean, I think that you can use security algorithms and keys and lockouts and things like that to enable the debug functionality remotely. These, as long as you do that in a way that cannot be hacked. Certainly you've got to have the ability to turn that off. And it's really do you need to debug it in the development? And then once it actually launches out into the market, how do you keep people from being able? I mean, that's the debug port's the best, one of the best
to hack into.
And it may not even be one that gets brought out. It's people will go in and do all sorts of crazy stuff to try to find this, even down at the chip level. Right. It's kind of a never-ending race of patching holes in some way. But yeah, that's certainly. I mean, the other thing is, the security's got it. There's a lot of times there's a trade-off between the way the security is implemented and how far you go. How much energy do you want to burn to decrypt the keys and do all that, and how much intervention do you want on the user's part? And a lot of times it's a trade-off between ease of use and security as well. For instance, on the light bulb, you want it to just work, and you want it. A lot of times, there are trade-offs in the product design in terms of the amount of security and how much risk there is. If somebody turns off one light bulb, maybe you might not care. But if you're in a city and you can turn on all the light bulbs at once, that kind of screws stuff up. So I think that a lot of times people tend to, just like in an engineering schedule, when you're trying to think up front how long it's going to take to do something, I think that in security, people don't think through all the bad stuff that can happen and tend to take shortcuts and not think about it enough in the product design and say, oh, that doesn't matter, that's not a big deal, or that won't take time, or, you know, and then actually it ends up coming and biting them. So I think that, you know, it's really just taking it seriously up front and really trying to think it through and making it as flexible as possible and adaptable over time as possible is the key.
All right.
Thank you.
Well, to not
All
screw
right.
up the schedule of the rest of DAC, I want to thank Tyson for
Thank you very much.
giving this talk.
Hold on, I got to put my coffee down.
Yeah, very good.
There we are.
Thank you so much, sir. This was
Thank
great.
you very
This was
much.
great. Got a couple shots.
Thank you,
Very
everybody.
good. All right. Everyone, have a great DAC. This is your last chance to see the exhibits. They're opening right now, and just head right and go right straight in.